Hey everybody, and welcome to Module 3 of the GDAZ Middle School program, Introduction to Geographic Information Systems. This is Lesson 1, Utilizing GIS Technology, and I'm Justin Ettinger from NAU. I'm Project Manager here on GDAZ. I'll be taking you guys through the presentation. And the topics we'll be covering in this presentation include an introduction and kind of review of GIS technology. We're going to talk about a few different types of GIS data, the importance of data attributes and being able to query that data, how that allows us to use GIS to perform spatial analysis and solve problems, and last but not least, ways that we can access GIS technology. So back in Module 1, Lesson 2, we introduced a technology known as Geographic Information Systems, and we talked a lot about how we use it as a data collection tool on the Lower Salt River Restoration Project. In this presentation, we're going to take a little deeper dive into GIS, and from this point on in GDAZ, you guys will get a ton of hands-on experience using GIS. So let's just refresh our memory real quick here about GIS. So Geographic information systems help to capture, store, and display and analyze data. And that data has a geographic location on Earth tied to it, right? It's a tool that we can use to show and analyze the spatial relationships that exist within different data. And we can use it as a model of the real world to solve problems and use spatial analysis. So again, if we pick apart the words, we start with geographic, right? Meaning some portion of the data is spatial. In GIS, we call this geospatial data, and it's data that references a location on Earth. So we saw this slide again back in Module 1, but I think it's important to review a little bit of terminology real quick. We have two different types of data in GIS, vector data and raster data. And vector data uses X and Y coordinates to represent the location of an object, right? And it's really the best for discrete or thematic data that has an exact location, like a city or a certain sign, a stop sign. A line would be a road or say a river, or polygon, again, representing an area. But it's discrete or thematic data, meaning it has an exact location. Whereas raster data is a representation of the world as a surface divided into a regular grid of cells or pixels, right? And so we use raster data to represent continuous data or data without a hard boundary, such as elevation data or precipitation data. And raster data can also include aerial imagery. The important thing to remember about raster data is that it's this grid of cells, right? And if we zoom in super far, we'll see those boxes or those cells. And those cells are going to represent a distance or a value such as precipitation or elevation or the reflectance of light. So let's take a quick look at this map here of Philadelphia. And this is displaying some vector data. So we have lines that are representing varying roads from highways to smaller side streets. We have points here. That point that the arrow is pointing to there is representing public transit stops. And we have varying polygons as well. So we see these maroon colored polygons that represent educational institutions. But we could also see a couple of green polygons in there representing parks, or gray polygons representing developed areas. And raster data. So remember, while vector data is best for discrete objects with an exact location, raster data is that grid of cells or pixels used to represent continuous data, such as like we see here, which is elevation across the state of Arizona, or precipitation data that we see here along the Gulf Coast. And aerial imagery, again, is another form of raster data. So whether it's vector data or raster data, the key is that we're using geographic location data to represent the real-world location of an object or phenomenon. And in GIS, our location data is generally coupled with tabular or attribute data, right? So that's the data that's representing the information about the object that we're considering. And so if we look at the example here, we can see that the attribute data is going to provide additional information about our spatial feature. So if our spatial feature, our location data, was the school's location, then its attribute information could be things like the school's name or the student-teacher ratio, what's the student demographic, the student enrollment, And these attributes tied to that spatial feature allow us to do spatial analysis to problem solve. And it's important to recognize the difference between attribute data or information and spatial data or location information. So here we see a picture of our team performing monitoring on our tropical reforestation effort in Puerto Rico. In the Excel sheet you see there is the type of information that they collect at each tree. So out of this table, which columns represent location information? Right, so there you see the latitude and longitude, right? And that is representing the location of each tree. So what about the attribution information or attribute information? And that's everything else, right? So everything else in this data sheet are attributes or information that they're collecting about each tree on that site. And it's that attribute information that really gives us the power in GIS, right? So we can use attributes to query certain data and set certain parameters or filter our data. So here we see an example where we have census data, USA census data, and there's an attribute within that data that is population per square mile. And so we can set this query or filter to show us all areas with a population per square mile greater than 2,000, right? And it's going to filter out just that area. And so we can use this attribute of information and this ability to query or filter data to perform certain analysis. And the system is what ties all this information together, right? And it allows for that spatial or statistical analysis to take place. And the result of that analysis then can be a thematic visualization or map. So here we can see a proximity analysis performed to display 5, 10, and 15-minute drive times from Phoenix Sky Harbor with typical traffic at 10 a.m. on a Monday. Right, so you can see those varying colors with green representing areas you can reach within 5 minutes to Sky Harbor. That kind of aqua green representing areas you can reach within 10, and that bluish polygon representing areas you can reach within 15 minutes, right? So imagine how this analysis might come out, or this map might come out looking if we perform the analysis for, say, 5 p.m. on a Monday instead of 10 a.m. So now when you're driving on the highway and you see that sign that states, oh, it's 40 minutes to so-and-so location, you can kind of imagine how they came to reach that calculation of time. And again, it's that combination of location and attribute data that allows us to interact with data in GIS. Taking a map of large cities represented by just these simple points to points whose size scale are based on the population of those cities. Or from simple polygons representing census tracts in the Phoenix metro and surrounding areas to polygons symbolized based on the population per square mile. So immediately you can see how this gives us the ability to visualize data in a spatial manner. So in this map, we see census tracts representing the location data, and population per square mile is the attribute data we use to symbolize the census tracts in a way that tells the story we're trying to get across. Okay, so I've repeated this phrase a couple times now, and that's that GIS allows us to visualize patterns and trends in data. So I want to talk you through a brief example of what this looks like. Here we see a map of the Compton area of Los Angeles, and those points on the map represent public transit stops. So let's imagine we're interested in whether there's a relationship between access to public transportation and poverty levels in LA. We could start by performing a simple density analysis of transit stops in this area. We see the result of that here, with darker purple representing the most access to public transportation. We could use the attribute information tied to census data to view the percentage of households with income below the federal poverty level. So our varying color gradient here goes from that light green to darker blue, representing nearly 30% of the population living under the federal poverty level. If we combine these two layers, we can start to visualize or identify a pattern or relationship between the data. At least for this area of interest, there seems to be a direct correlation between high poverty levels and access to public transit, with areas of higher percentage of poverty generally having more access to public transit. And this is important for a city, right? Because one of the key factors in being a productive citizen is being able to get around the area that you live. Let's switch gears a bit and consider a new factor. Now, I'm assuming you all have heard of something known as the urban heat island effect. But if you haven't, or you need a refresher, the urban heat island effect is the phenomenon of densely developed areas trapping and re-emitting more sunlight and heat than less developed areas, right? So all of that concrete infrastructure, roads and buildings, little greenery is going to absorb that heat and then emit that heat, not only during the day but at night. And this can have a plethora of negative impacts on urban areas, from increased temperatures and power usage to dangerous health effects. So what if we wanted to ask a new question? And that's, are low-income areas disproportionately affected by the urban heat island effect? We could use that same census layer that displays areas based on the percentage of households living under the poverty level in LA. So again, we have darker areas here representing close to 30% of the population living under the poverty level. And we can overlay that with the urban heat island effect data layer that portrays the hottest areas in a gradient of yellow to red. And again, at least within the specific area, there seems to be a pattern or trend between high poverty levels and areas heavily impacted by the urban heat island effect. Okay, so we've covered some basic GIS technology. We talked about how points, lines, and polygons or vector data can be used to represent objects. We talked about the importance of attribute information tied to the data and how those attributes allow us to interact with data in GIS. And I hope at this point you guys are all just itching to get your hands on some GIS action. So let's talk about how we can access this great technology. And we'll start with some open source technology that's available out there. The biggest, most popular one is called QGIS. So this is a free open source GIS desktop software. We'll move on to something called Arcgis, which is developed by a company called Esri. I like to think of Esri as sort of like the Apple or the Google of the GIS world, right? So they're the global leader in GIS software. And their suite of technology is called Arcgis. There's desktop versions. The newest one out is called Arc Pro. And lucky for everybody, there's online or web versions that don't require any software downloads or processing speed, a strong computer that can handle processing, because all of that processing is done on the cloud, right? And that's through Arcgis Online. Now, lucky for you guys, as members of the Green Zone AZ program, we've helped to get your school hooked up with the Arcgis K-12 school bundle. And that provides a free Esri Arcgis license to you and your teachers, giving you individual user accounts and access to Arc Pro if you wanted to take it to that next level and download the software, really experience the full power of GIS. But what we're going to focus on and use a lot during the spring semester here in Green Zone AZ is Arcgis Online. And Arcgis Online is a cloud-based, web-based mapping and analysis solution for creating and sharing GIS data and maps. And it's not just web mapping, there's also a wide variety of geospatial applications that are available through Arcgis Online. So you can use Arcgis Online to manage GIS data and share it with your organization or team. That left image there, we can see those yellow points. Those are representing trees at one of our sites in a reforestation project in Puerto Rico, right? So I can manage my database, our database for the Puerto Rico reforestation effort from my computer here in Chandler, Arizona, and my team in Puerto Rico can get live updates, be able to access that data on their tablet or phone immediately. So super useful. And you have access to a wide variety of GIS applications through Arcgis Online, everything from story maps to these field maps like what I just mentioned in Puerto Rico, Survey 123. We'll go through some of those as we go through the program here. And one really, really cool thing about Arcgis Online is access to the Living Atlas. So this is an abundance of GIS data and maps and ready to use analysis tools that are completely free and ready to go on Arcgis Online. All right, so let's do a quick tour of Arcgis Online. So I'm at arcgis.com. I'm just going to take you guys through a little tour, get down some of the navigating basics of using Arcgis Online. We have some great activities lined up for you all in this module that'll give you some real good hands-on experience of using this content. But So if I log in, it's going to bring me to my organizational page. So when you guys log in, you'll use your individual user account that you got through that K through 12 school bundle, the license that was provided to your school. It's going to bring you to your organizational page that'll look something like this, with this ribbon across the top. We can click on these little dots to access all of the applications that are available on Arcgis Online. So some really cool stuff here. You have story maps, which are a great way to kind of tell a story using data and maps as visualization tools. Survey 123 allows you to build custom surveys, which of course are tied to the location where that survey is performed. A lot of great tools out there and applications available. We can click on content to view all of the content that's associated with our own individual user account or groups that we're members of. For now, let's go over to map, and that's going to open up a new web map for us. So on the map here, you can click and drag to roll around. You can scroll up and down on your mouse or use the plus and minus buttons to zoom in and out. We can use the search bar on the top right to search for an area. So we can go over to Los Angeles, California, and currently we're looking at a base map that is an aerial imagery hybrid with some labels on there for places of interest and looks like streets, highways. We can change the base map by going to the base map gallery, and you can see a list of all the base maps that are made available on Arcgis Online. One of my favorites is the dark gray canvas. You see a lot of that in the presentations. Really great base map, I think, if you're trying to make some of the features that you have added to your map really pop. If you don't need to necessarily see what's going on in the background there, if you're really trying to show what exists in the real world in that area, then you probably want to use something like Imagery. But otherwise, you can play around with the base maps and kind of have some fun and make some nice looking maps. Alright, so let's see what happens if we search Compton, and we can get ourselves over to where we were looking at that LA Transit study. Now let's say I wanted to make a bookmark for Compton so I can quickly return to this area from other places on the map. So I can add a bookmark. Then I can be anywhere else in the world on the map and quickly return to that area by clicking the bookmark. Okay, so let's go ahead and add some data. We can go over here to the ribbon on the top left. By clicking content, we can see what's in our map. So we currently don't have any data layers added, so we can add a data layer. We can search for layers within our own content on Arcgis Online. We can use the Living Atlas, which is a large collection of data made available by Esri. We can add a layer from a web source or a file on our computer. For now, let's do the Living Atlas. And we're going to search public transit. If we click on any content, it's going to give us a description of that content, kind of what information is included in it, the source, analysis available that's through it. We can add it to the map by clicking here, or we can click the small plus icon. So that's going to add that vector data, right, points to the map representing public transit stops in this area. We can go back to our content and click on this. By clicking this table icon, we can view the attributes associated with this layer. So here we see that location information and then all of this other attribute information that's associated with this layer. Similarly, we could change the symbology by clicking the style, change style icon. Let's leave it the same for now. So in the presentation, we did an analysis looking at density of available transportation stops. That was in the Analyze Pattern section, Calculate Density. Since I've already performed that, I can add that layer from my content. And we see it here. And so again, those darker purple areas representing the high density access or availability to public transit. Let's go ahead and turn that off. So I'll go back to my content, just simply click the checkbox to turn it on and off. Or if I'd like to remove it, I can choose these three dots and just remove it from the map altogether. So let's add some more data from the Living Atlas. Now in the presentation I talked a lot about census data, and that's just because for me, seeing census data used in GIS is what really made it all click for me. It was immediately apparent kind of the ability that you have to really manipulate data and not only visualize it, but use it to analyze these patterns. So let's see what happens if we just search US Census. I mean, census data, they collect an incredible amount of information in the US Census. So here's my plug when it comes time to do the census: answer all the questions, answering them as accurately as you can, because real consequences come from that data, and if nothing else, it gives a great tool for us to be able to use for GIS analysis. So we can see things like populated places, household income. Let's look at the unemployment rate. Anytime you add a data layer to the map, you could zoom to that layer and it will show the full extent of that data. We can go to the legend to get an idea of what these varying colors represent. So here we have 2020 USA unemployment rate with averages from 4% to above 23%. Now the cool thing about this is the census data is available at multiple scales, right? So we can view this at a state level while looking at the whole country. We can zoom in to the state level and see things by county. We could zoom in further and look at it by zip code, even further by individual census tract and census block. So really cool capabilities out there. Now let's say we wanted to add some other data from our own Arcgis Online account. Let's go ahead and search for layers, and I'm going to search plant species. So here we can see a plant species inventory for our project on the Lower Salt River. By adding it to the map, this immediately brings us to that area. We can switch to aerial imagery. Now, it's nice that this is already symbolized for us, but let's assume it wasn't. So we can go to our content, and sometimes when you pull a data layer in, it'll just be symbolized as a single symbol, right? So this is all the polygons that represent this data set. But if we want to symbolize it by something that means something, we can use the attribute information associated with that data layer to symbolize it. We can choose an attribute. So here we have common name of plant selected, and that's going to symbolize all of that information by the plant name. So this is an inventory of plant species that we've mapped using our drone imagery on the Lower Salt River Restoration Project. Now we could change the transparency of this layer. Sometimes it's helpful to be able to see through some of the data that you're looking at, or stack different data layers. We can view the attribute information by clicking on the table again. So again, we chose to symbolize by this attribute of common name. So that just kind of provides some of the basics of getting around in Arcgis Online. You know, logging into your account, opening up a new web map, how to add layer. I really encourage, or how to add data. I encourage you guys to get in here, explore that Living Atlas. There is an insane amount of data available to use and analyze. Anything you can imagine is out there. And again, we have some great activities planned for you, so you guys will get some hands-on experience using this Arcgis Online environment. All right, so that's enough of me talking for now. You guys get out there, get through those lesson 1 activities, get some experience in Arcgis Online, and I will look forward to catching back up to you in Lesson 2. Take care.